Clear, clear.
Okay, yeah. Okay, so macam biasa saya record this session and I'll upload it in YouTube. So today we continue our revision with chapter 9, quantization of light. Okay, so previously we did question 10, chapter 10 and 11. Okay, so as just a little bit of summary, it's not like summaries, this is how you solve the problem in this chapter lah, just a technique. So whenever you get these questions in exam, first thing first, you drew the diagram. So to draw the diagram, just draw a straight line like this, okay? And then you draw the incident light. So this is the incident photon. Basically, this is the lights, huh? The lights going in, and then you have electron underneath the surface and electron being ejected. So basically, you can divide into three parts. Okay, one is the energy that is going in, and then we have energy of the work function. So this one is energy. This one energy of light. This here is light. And then we have work function. So this due to the surface. And then we have kinetic energy that is basically due to the electron kinetic energy. So the key thing here, we can write Einstein equation where E is equals to W naught plus K. And remember that E, W naught and K is basically energy. Sometimes they use a unit joule, sometimes they use the unit EV. As long as all the unit is the same, you guys should be okay. Okay. This is just a unit. It's just a unit. You just have to convert accordingly. And then over here for the lights, we have HF or HC over lambda. For W net, you will have similar formula, just that now you put not. Okay. Now for kinetic energy, you can either write this one as half mv square if you want to find the velocity, and at the same time this one can equals to E or K or EV. So all these three you can interchange for the last part ni. But normally they will put this one as K, kadang-kadang dia letak this one as EV S. So example, K you can write as EVS as well. Energy ni maybe tak kot saya padam balik lah sebab very rare lah for them to use the symbol E over there. So W naught you can write as HF naught or HC over lambda naught, and E is HF and HC over lambda naught. Again, I repeat, the key thing here is that you have to identify, sorry, just a lambda. Okay, the key thing here is that you want to identify, if they give you a lambda or F, that one represent E or W naught. Okay, that's the key thing. If you did that one correctly, then it should be okay. And then we also have two graphs. One with the shape something like this. You can double check later on. And then another one is a straight line graph. Again, you can study again about these two graphs. Dia tak susah pun. Yang straight line itu, basically from this formula, yang graph yang curvy tu sedikit tu, most likely they will ask you about stopping potential or intensity of light, the effects of intensity. Okay, so that's it for this topic. So now I want you guys to try to do question number 8. Okay, can you guys try to do question number 8? So they give you light frequency strikes a metal surface. Electrons are emitted. Work function is 2.3 eV. Calculate threshold frequency, maximum kinetic energy, stopping potential. Okay, so What is the first thing that you guys need to do?
Draw, sir.
Okay, draw. Good, very good. So you draw. Maybe I can draw it over here. Good. Okay, and then we have the photons coming in. Okay, dah lika belum? Anis, okay Anis?
Okay, sir.
Okay ya. Okay, so draw the diagram first. Once you draw, so saya assume kamu dah draw dah ni. Uh, Light frequency 1.15 times 10 to the power of 15, that one represent values of apa? I mean, if you want to write a symbol, the symbol would be apa? This one.
F je ke, sir?
Okay.
F, sir.
Okay. F ke F not?
F.
Okay.
F
So
not.
kalau okay, ada yang cakap F not, ada yang cakap F. Okay. Back to our diagram over here. Kalau kamu nak lukis, nak tulis F tu, dia tu dekat biru ni ke, dekat elektron bawah ni ke, dekat keluar ni? Biru, bawah,
Dekat biru, sir.
keluar. Okay, biru. Kenapa kamu cakap dia dekat biru?
Sebab dia kata light frequency.
Okay, light frequency. Yes, correct. So, F equals to 1.15 times 10 to the power of 15 Hertz. So, kalau dekat biru, that means dia adalah F. Dia bukan F not. Kalau dia dekat bawah tu, dia baru F not. Okay, and then they did give you the work function as well. Work function itu dekat mana? Bawah ke atas ke? Masuk. Masuk, bawah, atas.
Bawah, sir.
Okay, bawah.
Dekat metal.
So, correct. So, below here is the metal. You just write it over here. The symbol would be apa symbol work function?
W naught.
Okay, W not. So you already have W naught and F. Okay, the first question they want you to find threshold frequency. So what is the symbol for threshold frequency?
F not.
F naught. Okay, good. Boleh dah ni, boleh. Senyap pun boleh. Kawan senyap.
Okay, sir.
Okay,
Ada, sir.
ada. Okay, so kalau kamu nak cari F naught, kamu nak pakai formula apa?
W sama dengan HF not.
Okay, correct. So W naught equals to HF naught. So notice that you have a Planck constant over there, H2. So H is in SI, 6.63 times 10 to the power of negative 34. That means you have to use W naught in joule. So 2.3 times 1.6 times 10 negative 19. So you have energy in joule. Now press the calculator. Saya dapat tak?
Dapat, sir.
Okay, good. Okay, the next question, we want you to find the maximum kinetic energy. What is the symbol for that one? Maximum kinetic energy.
Kinetic.
Kmax, correct. So if you want Kmax, so what is the formula that you want to use? Yeah, I'm gonna correct this one. I just put max over here. So if you want to find Kmax, which formula that you want to use? So now you have energy over here. You can find, you don't have yet, but you can calculate the energy over here. The energy of the metal is given. So basically, if we want to find this kinetic energy, the energy that is going up. So, macam mana nak kira?
Sir.
Yes.
Dia guna formula yang Kmax equal to EVS.
Okay, kalau kamu nak pakai Kmax sama dengan EVS, kamu tak ada information EVS tu. Kamu tak ada VS kan? So VS tu dia tanya kat C. So VS tu tak ada.
F equal to W naught plus Kmax.
Yes. So you can use Einstein equation. Equation yang asal terbalik. So kalau kamu, macam ni cara dia. Kalau kamu nak cari energy kat sini, and you have the information over here, you can use like HF ataupun HC over lambda. Okay. Kalau kamu nak cari energy dekat sini, ataupun kamu nak cari lambda of frequency, you have a certain information, then you can use HF ataupun HC over lambda. Similarly, over here, if you have, let's say, stopping potential ataupun velocity of the electrons, then you can use half mv square or EVS. But the thing is, you don't have any values over here, so you have to use relation of these three. So the relation of those three is actually E, which is the incident light, equals to work function plus with the Kmax. Okay, so I'm gonna, for practice purpose, I'm gonna put a bracket over here to indicate that this one is ejected electron. Okay, you don't have to write that one. Let's put it over here because I just want to show you the work function which is due to the metal. And then of course we have E that is due to the incident light. So basically this equation you can take out from the diagram, your own diagram. So yang masuk equals to yang digunakan plus yang keluar. Okay, now, so you want to find Kmax. So it is basically E minus W naught. I can write Kmax equals to HF minus W naught. Okay. So you already have the values for F. Which is 1.15 times 10 to the power of 40. 15. And then you have minus W naught. And then W naught is given as well, 2.3 EV. But since one of these is as SI unit, this one is in SI unit because you basically calculate H kan. So this one you have to put in joule as well. So you have to convert to double darab. So this one is multiply with 1.6 times 10 negative 19. Okay, how much do you get kinetics?
Negative 3.2.
3.94.
Negatif. Okay, 3.94. Yang dapat negatif tu, double check balik. Saya takut tolak terbalik. 3.94 times 10 negative 19. Okay. Obviously, when you calculate the energy over here, you can convert to EV. Sorry. This one lah. You can convert to EV. So this one you leave it as 2.3 and then you get final answer in EV as well. That's another option. Okay, so both answer is correct, so shouldn't have any problem. Okay, C. The stopping potential of the electron. So the last question they want you to find apa? Stopping potential, symbol dia apa?
Okay, max sama dengan EVS.
Okay, correct. So Kmax sama dengan EVS. So kita nak stopping potential tu sebenarnya adalah ES lah. Asal terus kasih form dia. Okay, good. So Vs, if you want to find Vs, basically just Kmax, which is 3.94 times 10 negative 19 divided by 1.6 times 10 negative 19. Okay, biasanya nombor dia memang macam solid sikit lah. Tak adalah, tak ada prefix tu. Biasanya lah. So I got here is 2.46. The unit will be in volts. Okay, so one of the problems is that when you calculate Kmax and you get this one in EV, sometimes students confuse how do you want to substitute over here? Sorry, over here. So you can substitute, but make sure you have to change the joule. So that one is basically multiply with EV, multiply with E, so multiply with E and then divided by E, you cancel out lah. So final answer sama je. Okay, we got 2.46. Okay, any question? Soalan?
No, sir.
Tak ada kot, sir.
Okay. Siapa okay? Nasib jatuh je. Phone nasib jatuh kan? Okay. We move on to question number 7. Kita baca sama-sama. When a monochromatic light of frequency 7.9 times 10 to the power of 14 incidence upon a metal surface, the stopping potential needed to terminate the emission of photoelectron is 0.2 volt. Calculate the work function of the metal, the threshold frequency of the metal. So you can highlight key information. Light of frequency 7.9 times 10 to the power 14. Stopping potential is 0.2 volt. Calculate the work function and threshold frequency. Okay, the first thing, what do you need to do?
Kena lukis.
Okay, wait. Bagus. Very good. Draw a straight line. Okay, and then you draw the electrons. Okay, and then we have electrons. Okay. 7.9 times 10 to the power of 14. That one is your frequency, but which frequency? Is it the photon or the metal?
Photon, sir.
Okay, good. So that one is actually your photon, 7.9 times 10 to the power of 14. So if you got confused, the keyword is incidence. So the incident is the incoming. So that one is the lights punya frequency. So the F je lah, tak ada F not. Okay, and then dia kata the stopping potential to terminate the emission of photon iaitu 0.2 volt. So kau nak tulis kat mana? Down here or up here or over here?
Down.
Okay, so normally student will write VS tu dekat bawah sini because VS tu is basically depends on work function, betul tak? But dia actually lagi dependence dengan incident lights. So berapa banyak energi datang, berapa banyak energi keluar. Dia sebenarnya yang energi keluar tu lah. So VS tu sepatutnya kamu tulis dekat sini. And because VS is equals to EVS is equals to Kmax. So that's why we have it over here. So mana dia tulis? So untuk yang keluar is VS. Okay, that's the question. That's the two information that they give you. Question A1. They want you to find the work function. Okay, so that one is W naught. So W naught duduk dekat mana? Sini ke sini?
Dekat bawah.
Dekat bawah. So dekat bawah ni ada tak information lain yang kamu ada? Daripada diagram kamu ni kan? Did you see any other information down here? Yes or no?
No, sir.
No. Kan? So you basically don't have any values over here. So if you have a certain value like frequency or wavelength, you can calculate using HF or HC over lambda. But since you don't have any values over here, kamu kena pakai formula apa?
Guna Kmax equal to EVS.
Kmax sama dengan EV and then?
Lepas tu kan kita dapat Kmax kan.
Aha.
Lepas tu guna formula satu lagi.
Formula apa yang lagi satu tu?
Formula yang instant.
Okay, good. Okay, so the key thing about to solving this problem is that you have to use Einstein question. Just cakap lah. Kalau dia bersendirian and they want you to find the values over here, you have to relate with others. So basically, these three is the energy, so you just have to relate those three lah. So it will be E equals to W naught plus K. Okay, so you can find incident lights punya energy by using formula of HF. You want to find W naught, so I'm going to leave it like that. And the K is actually equals to EVS. So to solve this one, the W naught is equals to HF okay, the frequency berapa frequency di sini? The frequency is 7.9 minus EV. So the E is 1.6 times 10 to the power of negative 19. The value that they give you is the VS, which is 0.2. So ramai student dia akan terlupa darab ni. Sebab dia assume yang diberi tu adalah EVS. Tapi sebenarnya yang diberi tu hanyalah VS. So you have to multiply with E.
Dapat sir.
Saya dapat. Dah. Ah, mana saya tak dapat? Jawapan yang saya ada ni salah. Anyway, okay, double check. You should get 4.9, which is sama dengan yang jawapan dalam buku tu lah. Dalam buku kamu tu. 4.92 times 10 to the power of negative 19 joule. So, everything is in the SI unit, including the final answer. 7A2. How do you want to solve this one? So they want to find the threshold frequency of the metal. So what's the symbol for threshold frequency?
F.
F? Ada not ke tak ada not?
Ada not?
Okay, ada not. So, sebenarnya soalan ni nak cari F not over here. And now you already have the W naught. You can relate with that. So you can use W naught equals to H F naught.
H.
Yes. So it will be, okay, 4.92 times 10 negative 19. Again, make sure you write in SI unit because you have H over there. Over there. Okay, dapat jawapan tak?
Dapat sir.
Okay, good. Very good. Okay, try to do question B. I'm going to give you a few minutes to read up the question and try it yourself. Question B is basically not related to question A. I mean, it's a different question, but still in the same topic. Okay, so Chennai, that's the second. How do you want to solve this one? You have a laser and they give you the power and produce a light of a wavelength 633 nanometer. How many photons are emitted by the laser for 5 minutes? So the idea is something like this. So you have a beam of a laser. Okay. So the power is equals to berapa power dia? 7.5 milliwatt. Okay, the time is 5 minutes. And the wavelength is 63 nanometer. Double check the values. Okay, seems tally. Okay, so this is basically your laser beam. Okay, so your laser is going in this direction. Okay, so this is your laser like that. It's going in. So the laser actually consists of photon. Inside the laser, there's lots of photons, individual photons. Okay. So now, do you have any idea how to solve this one? Ada idea tak?
Calculate the energy, divide by the Planck constant and the C and the multiply the wavelength.
Okay. Yes, correct. So basically, the question wants to find the numbers of photon. So how many photons are inside here? So this photon, each one of these will bring an energy. Step 1 tu dia bawa energy. Itu kan 10 joule. 10 joule. So total up in this diagram ada 50 joule lah. So that's the concept. So here you want to find how many photons. You don't know how many photons, but you do know the energy over here and energy over here. So I think the Taiji mentioned just now is that you can calculate the energy of the photon by using E equals to hc over lambda, and that is actually the energy of the photons. Okay, and then to find the energy of the laser beam, yang kesemuanya tu, actually you can relate power with work. How do you want to relate power with energy? How do you want to relate power with energy?
Power times time equal to energy.
Yes. So from the definition of power is actually power is equals to change in energy with respect to time. So I can rearrange and this one becomes PT, the one that Taiji mentioned just now. So this one is 7.5. Okay, maybe I have to do it properly. I'm going to do it in different page to solve this one. So you can find E of the laser beam, or maybe you can put this one as E total. So it will be 7.5 times 10 negative 3. And you have to multiply with 5 minutes. Obviously, the unit for energy is, the unit for power is joule per second, which is in watt. So you have to change to second. Minutes change to second. So it will be 300 multiplied with 7.5 times negative 3. I got over here is 2.25 joule. So this is the total energy. So you have to find for each one of those photon how much energy that it brings. So you can write as E of the photon, which C over lambda. So if you press the calculator, I got over here 3.14 times 10 negative 19. Okay, so what is the next step? You have the energy for individual photons, and you already have the energy of the whole thing. So, how many photons are there?
Bagi ke sir?
Bagi. So numbers of photon we will put as n is equals to E total divided by E of a photon. So this one will be 2.25 divided by 3.14 times 10 negative 19. So you get 7.16 times 10 to the power of 18. Okay. Ada yang tak faham tak?
Dapat sir.
Faham ke tak?
Faham sir?
Faham.
Okay. So this one, they actually asked this question in 2017, 2018, if I'm not mistaken. Yeah, 17 and 18. So this one is quite new. That means it is within your syllabus. So I'm not surprised if they ask similar question. So it's not a direct question. You have to think a little bit. Let's say dalam satu exam tu ada satu soalan lah. And this year, that year, 17, 18 tu, this is the question that you have to think a little bit. Okay, so that one is okay. So we solve 7A and 7B. Okay, now maybe we can try to do question number 6A. Okay, the energy of a photon and the kinetic energy of an electron is the same in vacuum, which is 6 electron volts. What is the velocity and the wavelength of the photons? And obtain the wavelength associated with the electron. Before I forget, actually saya nak mention kat atas ni, actually over here, saya ingat saya nak cakap apa. Over here, they use the concept that photons tu actually adalah discrete amount. Dia quantize, dia seketul-seketul. So you can imagine ni macam ketulan beras. Setiap satu ketulan tu 2 gram, 2 gram, 2 gram. And the whole thing is total up lah. Segenggam beras. Dia macam tu. Photon ni nampak dia macam continuous, tapi dia datang tu sebenarnya adalah seketul-seketul. Macam kita tak nampak. Okay, going back to question number 6A tu. Okay, they want you to relate what is the velocity of a photons and an electron. So basically this question, they want you to differentiate between photons and electron if you have the same energy over there. From question number 6A, what is the information that you can take out from the question itself? Ada 6 EV tu kan? So 6 EV ni represent
Yes,
apa? What does the 6 EV represent?
Energy of a photon.
Energy of a photon. So if I put energy of photon, maybe I can write this one as E. Okay. But this one is for photon. At the same time, cakap yang this one, apa maksudnya ni? Saya buat saya ni kan pakai baju merah. Itu maksud saya. Okay, back to my question. So, what does this one means? Kinetic energy of an electron. So, just now dia kata energy of a photon. Kinetic energy of an electron. Kamu nak tulis simbol apa? Kinetic energy simbol apa?
K ke C?
Okay.
E.
So this one is for electron. Okay, what is the difference between photon and electron? Apa beza dia? Photon tu cahaya, electron tu particle. So it's two different things. Okay, so they said that you have the same energy. Okay, walaupun dia tulis EV, this one is energy. Dia bukan cuma dia dalam unit EV. Bukan joule lah. Okay, what is the velocity and the wavelength of the photon? So how do you want to find the wavelength of a photon if you have the energy? E is equals to anyone? Halil, Naim, Pul, Masya dah senyap lah. Macam mana? Kamu ada NG, kamu nak cari velocity dengan wavelength. Okay, kita fix. Kita tengok velocity one by one. Okay, velocity of a photon. What is the velocity of the photon?
The speed of light, constant.
Yeah, because photon is basically is a light. So light move at a constant speed, which is speed of light lah. So speed, velocity, okay, this one you don't have to calculate. You just have to state. Cakap je lah. Tulis kat situ. Okay, now back to another question. Dia kata wavelength of the photon. So they want to relate E dengan lambda. So what is the relation between E and lambda?
HC over lambda.
So E sama dengan HC. Ada pun HC over lambda. So lambda we can write as HC over E. Okay, but make sure since we have H over there, so you need to use everything in SI unit. So 6.63 times 10 negative 34 multiply with 3 times 10 to the power of 8. The energy is given, which is 6. But this one is in EV. Let's have to convert to joule, which is 1.6 times 10 negative 19. When we do that, you get lambda to be equals to I got over here is 207.19 nanometer. Okay, or alternatively, you can write this one as 2.07 times 10 to the power of 5 pun boleh, tak masalah. Sorry, 2.07 times 10 negative 7 meter pun boleh juga. Okay, now question number 2. You want to find the wavelength associated with electron. So for first question, they ask you about photon. The second question, they ask you about electron. So I'll just bring the information down here. So how do you find the wavelength? If you have electron. So wavelength of a particle. Kita belajar semalam. So mana nak cari wavelength particle? So basically soalan ni actually adalah chapter 10. Tapi dia mix up dekat dalam soalan chapter 9. Dulu dia memang selalu buat macam ni. Kalau tak ada lah.
H over square root 2me tu sih.
Okay, betul? So you can either use dia actually ada two formula je for chapter 10. One is lambda equals to h over p, another one is lambda equals to h over square root of 2 and ev. So student nampak ev tu biasanya nak pakai formula ni lah. But actually if you want to substitute the k, the formula now becomes 2 and k. So ev ni you can write as sans k ke e ke or ev. So tiga-tiga ni boleh. So depends on the information given. Since they give you kinetic energy, I just write over here as k. Kalau kamu main sebat masuk, kebetulan dapat betul, tu memang rezeki kamu lah, memang masuk dapat pun. Tapi yang sebenarnya dia sebenarnya masuk dekat k. So if I substitute over here, then it would be 6.63 times 10 negative 34 divided by square root of 2 mass of electron, we are talking about electron, and multiply with the k, which is 6 times 10, 6 times 1.6. Why do I have to multiply with 1.6? Because that one's in EV, I have to convert to joule. But here's 5.01 times the negative 10. And this one is in meter. Okay. You managed to get the same answer with me.
Sama sih.
Sama ya. Okay, I think the rest of the question you can try it yourself. Okay, so next week kita akan jumpa. Remember next week we will have the lab session. Lab lah, kita akan buat kelas kat lab. And I'm gonna do similar things like what we did today. Okay, kita buat kat lab ya. Okay, any question? Kalau tak ada kita berhenti dulu for today. Okay, okay, well.
Okay, sir.
Okay, so we start here now lah. Thank you everyone. See you guys next week.
Thank you,
Yes,
sir.
9:10 plus. Okay, alright.
Sir.
Okay. Okay.
Thank you, sir.
Thank you sir.
Yes, sir.
Alright. Okay.
Thanks, sir.
Okay.